Look at this. A massive, roaring gas giant, 300 times the size of Earth, orbiting its star so close that its atmosphere is literally on fire. Now look closer. Right next to it, in a place where it should be physically impossible, is a small, fragile mini-Neptune. In every computer model we have, this shouldn't exist. A hot Jupiter is a cosmic bully. Its gravity is so violent that it usually kicks every other planet out of the system or swallows them whole. Yet, here they are, dancing together 190 light-years away in a system called TOI 1130. NASA is calling it space's oddest couple. But at Quantum Fact Zone, we think it's something much more disturbing. It's a glitch in the rules of planetary birth. And it's proof that we might be completely wrong about how solar systems, including our own, are actually made. To understand why this is a nightmare for physicists, you have to understand the Standard Model. Usually, gas giants like Jupiter form far away from their star, in the cold, frost line, where ice can stay solid. Then, they migrate inward. As a hot Jupiter moves toward its star, it acts like a cosmic wrecking ball. It clears its path. Any smaller planet in its way is either flung into the dark void of interstellar space or pulled into the giant's crushing core. That's why hot Jupiters are almost always lonely. They are kings of a graveyard. But in May 2026, the James Webb Space Telescope looked at the atmosphere of the smaller planet, TOI 1130b. And what it found changed everything. Using its powerful NIR-SPEC instrument, Webb peered through the thick clouds of the mini-Neptune. Scientists expected to find a simple, thin atmosphere. Instead, they found a heavy atmosphere, choked with water vapor, carbon dioxide, and sulfur dioxide. This is the smoking gun. A planet can't get an atmosphere this heavy if it was born close to its star. The star's heat would have stripped it away before it even finished forming. This means this little planet wasn't born here. It was born far out in the cold, frozen reaches of the system, just like its giant neighbor. They didn't form separately. They formed together. And then, they traveled together. But how did the bully not kill the lamb during a journey across millions of miles? The answer lies in something called mean motion resonance. Think of it like a perfectly timed cosmic dance. For every one orbit the giant hot Jupiter makes, the smaller mini-Neptune makes exactly two. They are locked. Every time they get close to each other, their gravitational tugs balance out perfectly. It's a resonance that acts like an invisible tether, keeping them from colliding or drifting apart. But here is the terrifying part: resonance like this is extremely rare and incredibly fragile. A single passing asteroid, a slight change in the star's radiation, or even a minor shift in the gas disk should have shattered this balance millions of years ago. Yet they are still here, surviving against odds that are nearly zero. If a hot Jupiter can have a neighbor this close, it means our search for Earth 2.0 just got a massive upgrade. We used to ignore systems with hot Jupiters, thinking they were barren deserts. But if mini-Neptunes can survive the migration, then maybe rocky, Earth-like worlds can too. But it also raises a darker question. Our own solar system is orderly. The small rocks stay inside, the gas giants stay outside. We always thought we were the standard. But as we look deeper with James Webb, we're realizing that we might be the weird ones. We might be living in one of the only solar systems that actually follows the rules. The TOI 1130 system isn't just a curiosity. It's a crack in the foundation of planetary science. It proves that the universe doesn't care about our standard models. It builds what it wants, where it wants, and sometimes it leaves us the clues to prove we've been wrong all along. What do you think is keeping this impossible pair alive? Is it a lucky coincidence of gravity, or is there a force in the protoplanetary disks we still don't understand? Let me know your theories in the comments. I read every single one. If you want to stay ahead of the glitches in our reality, and see the images that are rewriting the textbooks, hit that subscribe button right now.